So, hello everybody, welcome to a new video of Time Well Invested, where in our previous video we talked about the scientific endeavor, where we learned a lot about science, all the common stuff about science like laboratory apparatus, hazard symbols, etc. etc. And we also learned about the Bunsen burner, and that was all for the scientific endeavor, which is usually what's covered in WA1. Now we will be moving on to a new topic: elements, compounds, and mixtures. So, this is one of my favorite topics because although it's really, really basic and a little complicated, but it's super interesting, intriguing to learn. Okay, so elements, compounds, and mixtures is part of chemistry, which all of us will be learning about in Sec 3, or I think starting Sec 2, where we'll be learning chemistry, biology, and physics. So it will be three sciences, but elements, compounds, and mixtures is part of chemistry, which is one of my favorite. Okay, so without further ado, let's start. So, you all might be asking me, what is an element? So an element is pretty easy. An element is the basic building block of living and non-living matter. An element is a pure substance as it contains only one kind of particle. Okay, there's also one more thing: an element cannot be physically or chemically broken down into simpler substances. Okay, so that is an element. It is a pretty long definition, but it is the definition of element. So let me just drag this here. Oops. Never mind. Okay, so that is an element. So you guys might be asking me, okay, you've told me the definition of an element, but what actually is an element? So you all might be asking me, what are some examples of element? Okay, so some examples of elements include carbon, nitrogen, helium, neon, sulfur, iodine, xenon, radon, mercury, iron, cobalt, sulfur. Oh shoot, I already did sulfur. Sodium, calcium, and many, many more. Later, we will learn all about these when we talk about the famously known periodic table. Okay, So before we move on to the periodic table, we'll have to understand the periodic table. So this topic of elements, compounds, and mixtures refers to both elements, compounds, and mixtures, while referring to all these things about elements, compounds, and mixtures. It's referring to periodic table. Okay, so we need to understand how are elements classified, because obviously the periodic table is not just a table that's made out of the blue. It obviously follows some kind of pattern, which is how the elements are classified. Okay, so okay, let's see, let me take a new color for mine. Okay, so they are classified in, oh, what, in metals and non-metals in the periodic table. Later, when we dive in more to this topic, we'll understand what metals and non-metals are. Also, based on their properties they possess. Okay, so that is all for elements. Now we will be moving on to the famously known periodic table. Okay, so what is the periodic table? So all of us know the name of periodic table, but what exactly is periodic table? The periodic table is a tabular arrangement of the chemical elements ordered by their proton number. So when we move in more to the topic again, friends, we will learn more about what proton number is, okay? This ordering shows periodic trends such as elements with similar behavior in the same column or groups. So friends, you don't have to memorize this, because this is only what is the periodic table. This is just for your understanding, to understand what the periodic table is. But in the exam, don't worry, they are not going to ask you what is the periodic table. Okay, they're going to ask you a more harder question. Okay, so let's understand what is proton number. Now, the proton number can also be known as atomic number. Okay, so you can call it proton number or atomic number. So, what is proton number? A unique number that is assigned to all the elements. Okay, so how are the elements in the periodic table represented symbolically? So, firstly, first letter is written as a capital letter. Secondly, second letter is written as small letter. Okay? So, now let us see the famous periodic table. So, friends, this is the famous periodic table of elements which everybody know. Okay? So, now I'm going to draw a zigzaggy line. So, if you have an older sibling or like your parents have studied in the mainstream Singapore school and they still have their periodic table of elements with them, you will see them draw this line. Okay? So, this whole side, so this whole side here represents non-metals. Okay? So let me erase it so that you guys have a clear view of this. Whatever is on the other side of this line is a non-metal. And friends, there is an exception in the periodic table. This hydrogen thing here is also non-metal. Okay? And the rest over here, these are all metals. So that is what I mean by non-metals and metals. Okay? So friends, that is a non-metal. Now, you may be asking me, the symbolic representation of the elements in the periodic table is usually by the first letter and the second letter. Now, for example, we take this iron. Okay, we are taking this. Now, you guys might be asking me, I run. What is Fe? So, by right after what I'm saying, I run, it should be IR, right? Right. But this is Fe. So clearly I must have done some mistake explaining you guys. No friends, I have not done any mistake in explaining you guys. This Fe you see here is the Latin name of iron. So there is a Latin name of iron with the first letter starting as Fe. I can't remember the name, but there's Fe. So there is a Latin name which is Fe. Okay? So now you guys might be asking me, hey, look at boron. Boron is starting with a B. So its chemical symbol is B. You can see it over there. Look. So now you guys might be asking me, if iron uses its Latin name, then why isn't it not I? Agreed that we don't want it as IR. Or sorry, it shouldn't be like that. IR. We don't want it like that. So, by what I am saying, clearly because of the boron thing, our iron should be just I. But, friends, if you observe this little thing over here, Iodine. This thing already has an I. Don't believe me? Look closely. This over here is nothing but a I. So, if we take a I and put it as this, then it will be I here and I here. So, wouldn't people be confused? Exactly my point. That is why, friends, the periodic table works mysteriously because we are taking the Latin names of all of these so that we avoid confusion. Okay? So, for example, cuprum. Let's find where cuprum is. Oh, this is a little tough. Cuprum. Let's see. Okay, looks like cuprum I can't find in this. But friends, there's this thing, cuprum. Now you might be asking me, I paused the video. I looked at the whole periodic table, but I did not find cuprum. That is because cuprum is copper. You got fooled, right? Cuprum is the Latin name of copper. Don't believe me? You can ask Google. That's why if you see copper, let's try to find copper in the periodic table. Let's see. Copper. No, not cobalt. Copper. So we have copper over here, but we don't have cuprum. And you can see copper is CO, but we have a U. That's because of cuprum. So you guys got fooled, right? Of course, everybody gets fooled by this cuprum. Friends, let me give you another example. Search for hydrargyrum. You search the whole periodic table, nook and corner, but you won't find it because that is the Latin name of mercury. So, mercury, this is the normal name which we all know it as. And this thing here is the Latin name. Okay? So that is the Latin name of mercury. Okay? So friends, enough about the periodic table. I've already told you guys about the periodic table. Now, before we move on, you guys might be asking me, now that I've explained the periodic table, everything has a reason in the periodic table, right? So you guys might be asking me, what's one? Oh, what's one? What's two? What's three? What's four? What's five? What's six? What's seven? What's eight? What's nine? What's 10? What's 11? 12? So on all the way to 18. And then later, if you see past your papers, you will also see a 1, 2, 3, 4, 5, 6, 7, 8, 9 over here. So you guys might be asking me, what is that? I'm super confused. Well, friends, it's nothing to be, you know, scared of or feel weird of. Because all of this is group. Oh, sorry, no. Or yeah, group. And down here is periods. So now you guys might be asking me, what is a group? What is a period? Which brings me to my next point. What is a group? A group of elements is a vertical column of elements in the periodic table. So before I move on to periods, friends, I want to bring you guys back to elements. So about elements, you guys might be asking me, how does an element look like? An element looks simply just like this. And if it's a boron, it's just going to be a B here. That is an element. So that's simply just an element. An element is just circular with a B. Okay? So that's how an element looks like. Let me rewrite this. Okay? Oh, wait. Sorry, the title is wrong. I just realized. Next, what is a period? A period of elements is, oh my god, is a horizontal row of elements in the periodic table. Okay? So, now that we are done with elements and the periodic table, let's move on to metals and non-metals. So, what are some examples of metals and non-metals? Okay, so example of metals, as I have told you, example of metals are copper, iron, zinc, mercury. And examples of non-metals is hydrogen, oxygen, and carbon. Okay, so now what do you observe about the elements as you move from left to right across each periodic table? So from left to right Observation. So what do you observe when you go there? The element decreases in metallic character or increases in non-metallic character. Okay, so yep, that is the observation which you make. Now, a very important thing, differences between metals and non-metals. Now, this is very important because this is always tested in the exam. So, this is going to be the, I'm going to make a table. This is the property, metals, non-metals. It's going to be our title. So, let's see firstly melting and boiling point. Metals have high melting and boiling points, while non-metals have low melting and boiling points. Okay. Secondly, we have electrical conductivity. Metals can conduct electricity. Usually, non-metals usually does not conduct electricity. Okay. Then next we have oh, oh, next we have thermal conductivity. So this one is a good thermal conductor, while non-metals are poor thermal conductors. Fourthly, we have malleability. So you guys might be asking me, what is malleability? We will learn that in our next section of this video. So metals are malleable while non-metals are brittle. Then we have ductility. So metals are ductile while non-metals are brittle. The same thing again. Then number 6, we have their appearance. Metals are shiny when polished, while non-metals are dull. Okay. Number 7, we have sonorous. So metals are sonorous, non-metals are not sonorous. Okay. So these are the 7 differences between metals and non-metals that are usually asked in examinations. So now you guys might be asking me, what is malleability? What is ductile? What is sonorous? So let's go through them. A substance is said to be malleable when it can be beaten into sheets. Okay. Next, ductile. A substance is said to be ductile when it can be drawn into wires. And thirdly, sonorous. A substance is said to be sonorous when it can produce a ringing tone when hit. So friends, that is all I have for you guys today. Today we have covered elements and periodic table and differences between elements and metals and non-metals. Okay, and we have learned three new terms: malleability, ductile, and sonorous. Okay, so that is all I have for you guys today. Do remember to subscribe to our channel. Do remember to share this video to all your friends so that everybody can learn something new every day and we all can ace our examinations. So do look forward to our next video upcoming, and I will see you in our next video. Bye bye.